Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, next permutation. Okay, so what the problem is saying is we'll be given an array representing a permutation. We want to implement the next permutation that rearranges the numbers into the lexicographically next greater permutation. If no such permutation exists, rearrange the numbers into the lowest possible order. Okay, that is sorted in ascending order. A permutation of n numbers is any possible arrangement of all the integers in the range 1 to n, where each integer occurs exactly 1. Okay. So looking at the description, it's not very intuitive. I mean, even if you look at the example, you first if you read once, right, you don't understand like exactly what is the problem or what we need to do. Okay, so let's quickly understand what the problem is trying to say. Okay, so what the problem is saying is we'll be given an integer array. Okay, and we want to find the next permutation. Okay, we want to find the next permutation of the number. Okay, of this number. So consider this as one number. For example, 241750. This you can consider as a single number. Okay, it's okay, and wherein each digit is an element in the array. Okay, so what we want to do is we want to find the next permutation of this number. So what is next permutation? So what I'll, in easy terms, I'll say you want to find the next greater element. Okay, okay, which comes in the order. Next greater element of this particular number, which is the next greater number of this particular number. Okay, and the next greater number needs to have all the digits, all these digits only, all these digits only. So what will that number be? That number will be this. For example, what that number will be 245017. So this is the next greater number after this particular number, after this particular number. Okay, that's what the problem is asking us, to find the next greater number or next permutation. Okay, and what do we mean by permutation? Using these digits only, we want to find the next greater, just the next greater number after this particular number. Okay, which is again lexicographically next greater permutation, we can say. Okay, so that's what the ask is. Okay, I hope you have got the ask. Okay, now how can we solve this problem? Okay, how can we solve this problem? So for example, here let me write the input array again, 241750, and this is the output, right? This is the output. Okay, now how we can solve this problem? What we can do is we'll go step by step. Okay, we'll go step by step. So just one request: if you understand the intuition, if you understand the solution, then please subscribe to the channel, like the video. Okay, okay, so thank you so much. So let's quickly see. So here what we're going to do is we'll have our eye pointer placed here. Okay, sorry, we'll have our eye pointer placed at the second last element. Okay, and we are going to check for the next element, each and next element we're going to check. So we are checking for the descending order. Okay, so where the descending order breaks, we are going to stop there. So we are going to check, is this current element greater than the next element? Is this current element greater than next element? Yes, it is. Then decrement I. Is this current element greater than the next element? Okay, yes, it is. Then decrement I. Is this current element greater than the next element? No, it is not. Then we'll break here. Okay, so I will be pointing here. Okay, so let's code step by step. Okay, so first I'll show the Java code followed by C++. Okay, let's have first our n add.length. Okay, int I equal to n minus 2. We want to start from the second last element, right? We are going to have a while loop. Okay, which will be I greater than equal to 0, and the condition is air of I. The current element needs to be greater than the next element. We want to check for the descending order. So where the descending order breaks, we want to break the while loop. So here, just be with me to understand what we're doing here. Okay. So here our descending order breaks. Okay. Here our descending order breaks. So this was the first step. I is pointing here. Now the second step, what we're going to do is we will start with a J pointer from here, from the end. We'll start a J pointer from the end. Okay. Now why we are doing this? Just okay, because like, yeah, it's a process to find the next greater element, right? So what we're going to check here is wherever wherever r of j becomes greater than r of I, wherever r of j, right? R of j is starting from here, j is starting from here, and I is here, right? I is fixed, I is here. Wherever r of j becomes greater than r of I, we want to break there. Okay, so let's code. Okay, so what are we going to check here? For example, first of all, if I needs to be greater than equal to 0, right? So if it is only I greater than equal to 0, that means Now we can find the next permutation number. Otherwise, if everything is descending order, for example, 3, 2, 1, if this is the case, this is the input array, right? This is the input array. There cannot be next permutation number for this particular array because this is the last. This is the last in the permutation order. You cannot have. Can you have greater element using these digits only? Can you have some greater element using these digits only? No, this is the maximum number which can be formed from these two digits. Okay. So what the problem is saying is, if such is the case, if no such permutation exists, we want to return the numbers into the lowest possible order, that is sorting in ascending order. Okay. So what we want to return is, we want to return in ascending order. That's what the problem saying is, if no such permutation exists, we want to return in ascending order. That is the first. You can consider the cycle. This is considering these three digits. This is the first in the permutation and this is the last in permutation. If this is the last number, we want to go to the first number. We want to go to the first number. Okay. So also let me, for example, so when if I is not equal to greater than 0, that means there's no permutation. Okay. There's no like the all the elements are in descending order only. That is, they are at the last. They are the last number in the permutation order. So here what we want to do is, if such is the case, we want to just sort the elements in the ascending order. So simply what we can do is, rather than sorting, we can just reverse, right? What will be the reverse of this? 1, 2, 3 only, which will be what? Which will be sorting in ascending order. So we'll implement this later on. Okay, we'll implement, or maybe let's implement right now. Reverse, we'll write a function, we'll pass arr, right? 0 and n minus 1. We want to reverse the complete array. Okay. So just be with me, you'll understand what we are doing here. Okay, void reverse, right? Int arr, int I, int j. Okay. And what we're doing here is, while we were reversing, right? While I less than j, just swap now the elements, right? Just swap the elements. I have, like in yesterday's video also, we have seen the rotate, and day before yesterday also we have seen the reverse, right? So I think you should be familiar now. Okay, arr of I equal to arr of j, and arr of j, this is the reverse we are doing, right? Equal to 10. So we have reversed, we want to increment I and decrement j. Okay. So this function will take care of the reversing of the elements, right? So we are done here for the elements which are last in the permutation order. Okay. Now let's come back here to this. Let me undo this particular case. Now coming back to here, right? To this particular example, our I is here, and we are going to start a j. We are going to start from last, and we are going to find out. We want to find out the element which is just greater than this one, which is just greater than this number 1. Okay, the element starting from here, right? So let's code. So yeah, so what we're going to do, in j equal to n minus 1, right? Here what we have to do, while j is greater than equal to 0 and arr of j, if it is less than equal to arr of I, then keep on decrementing j until we find a number which is just bigger than the number at ith position. So here is a number at ith position, right? So for example, j is starting here. Okay. So according to our code, according to this code, what we are saying here, if arr of j is less than equal to arr of I, keep on decrementing j. Keep on decrementing j. So here arr of j is 0, which is less than arr of 1. So we are going to decrement j now. Okay. We are going to decrement j here. Now we are going to find, is arr of j less than equal to arr of I? No, it is not. So we will break here. We'll break a while loop. Okay. Now, simple. What we are going to do now? So what is the case now? 2, 4, 1, 7, 5, 0. So our j is pointing here. Our I is pointing here. So now what are we going to do? We are just going to swap these elements in order to find the next greater element, right? So we're just going to swap the elements. So how it will look like? 2, 4, 5, 7, 1, 0. It will look like this. So okay, it will look like this. So what are we going to do? Just swap again. We will write the same code here. Swapping arr of I and arr of j. Okay. Okay. We have done this. Now, okay. So this was the second step. Now the other step is what? To whatever was descending, right? So Sorry, just hold on. Uh, I need to charge my laptop. Now, after the second step, this is the state of the array, but it is still not just the next greater number. It is a greater number than this particular number, right? It is this number is greater than this particular number, but it is not the next permutation number or the just next the greater number, right? We still want to do so now this is after this, right? After this in the descending order. So what we want to do is we simply want to sort this or reverse this in ascending order. So how it will look like if I reverse this part? So 0, 1 and 7, right? And we already have this 2, 4, 5. So in this way, this will give us the next permutation number or the next greater, just the next greater number. Okay. So simple. So let's reverse. So now what are we going to call? Add, right? I plus 1 and n minus 1. That's it. So what was I? I is pointing here, right? I is pointing here. We had swapped the element, right? I is pointing here. So what we are saying is I plus 1. Reverse from I plus 1 to n. To n. So this is what we get. And we have already written the code for reverse, right? We have already written the code for reverse. Okay. So I won't explain the reverse. I think it is self-intuitive, right? It is self-intuitive. We are just swapping the two, right? The two endpoints, for example, right? Let me quickly explain this also. 710. I is pointing here, J is pointing here. So what we are doing is we are swapping in the reverse, right? We are swapping. So it will look like this: 0, 1, and 7, right? I was pointing here, J is pointing here. Now we are going to increment what? I. We are going to increment I, decrement J. Now both are equal. So we are going to break because our condition is I should be less than J. Okay. So this is it. This is a code. I hope you have got the code. I have tried to make it very easy for you. Okay. Let's submit it. If you have got the solution, the intuition, then I'll request you to please subscribe to the channel. Okay. There's some issue. What is the issue here? 151. You've got the output. Let me check. What is the issue? Okay, so I think 511. Again, here the next permutation number, it is not possible, right? It is not possible because this is the last in the permutation order, 511. You cannot have a greater number than this one. Okay, so I just made a mistake here. So here it needs to be, even if, for example, if it is r of I is, if it is greater than equal to r of I plus 1, then also like decrement I. Okay, then also decrement I. Okay, so let me submit this. This should be working. Okay, the test cases are passed. Thanks for watching. Let's quickly see the C++ code. It's almost same. Please subscribe to the channel, like the video. Okay, thank you so much. So here, like we are seeing array of size, definitely n we have taken. Here I have self-explanatory. It is the same in Java. Okay, only difference is where the swap, right? We are using the internal library function. Okay, so that's it. I think almost everything is same. I'll attach the code in the comment section. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Have a happy, healthy, and a great day. Thank you so much.